Hey everybody, it's your same logic instructor back again. This time I'm going to be illustrating some indirect proofs. This is the second of the two sub-proof rules that got introduced in Unit 9, and so these are slightly different. This one is maybe marginally less intuitive, but once you're getting comfortable with conditional proof, you should really have no problem with indirect proof, right? So now I'm going to start. Okay, so I'm starting with 9(5a), just to sort of get the ball rolling. Notice that here we've got our sought for conclusion is this little lonely negation of t all by itself. So not t is the goal. That's what we're trying to prove. And so obviously, maybe it's obvious, it doesn't seem like conditional proof is going to be much help since that's not a conditional. All right, so where would we write it down? Well, again, we draw the main line of our proof structure, and we've got not t at the bottom. That's where we're trying to go. That's our sought for conclusion. Now, indirect proof, to the extent that it's intuitive, is intuitive for the following reason or in the following way. The idea is that you might not see a way to get to not t directly, right? There just isn't anything obvious that you can do. So what you do instead is you adopt the strategy of assuming the opposite of the thing you're trying to show and then reasoning to a contradiction. So let me say that again. What you do in indirect proof is argue indirectly to your sought for conclusion. How do you do that? You assume the opposite of what you're trying to show, and you show that that opposite thing is contradictory. And so the thing you want must be true. That's the thinking. So let's try it. Well, we've got not t, so what's the opposite of not t? That's right. So here's your subproof structure, right? And you're just going to write t in here. That's the idea. So that's at step 4, right? And very like conditional proof, each one of these are your premises, right? So you write that down. And then here you've got assumption for IP. That's indirect proof. It's also called reductio ad absurdum, but that doesn't matter. I'm going to go back over here. So now what? Well, one thing you notice is that you don't actually have any conclusion written down here at the bottom of this subproof structure. So in that way, it's not like conditional proof. But you know you're going to try to get something, right, that's a contradiction. So in order to illustrate that, we're just going to write a sad face, right? So that's supposed to tell you what you're looking for is some contradiction. It could be any contradiction. It's got to be explicitly contradictory, though. And that means that it's going to have the following form, P and not P. It's going to be something like that you're going to have in this last spot, right? And when you get there, you're done. You will have discharged the assumption and you've moved back to the main line and proved the thing you're trying to prove. Okay, so far so good. What are we going to do next? Well, now we've got our t, like very conveniently, we can use that with the first step, at step 5, just on standard old modus ponens. So I'm entitled to write down A or B here, right? And again, that's modus ponens, our old friend, steps 1 and step 4. Now what? Well, I mean, here again, it might not be obvious or feel obvious to you, right? So but think for a minute. You've got all kinds of rules that you can use. And one of the rules that you have, right, is biconditional exchange, right? So you've got a biconditional here, B if and only if C, but that means the same thing as this. If B, then C, and if C, then B. Right, so let's write that down. And what's our, oh yes, biconditional exchange, right, on line 3. So that's one thing that we can do. Another thing we can do is do a De Morgan's here, right? So let's try that and see where that leads. So here we've got not A and not C, right? Because De Morgan's just drives that negation inside and changes that sign, right, to the and. So you've got not A and not C by De Morgan's, right, on line 2. Now you might see that you can do something. Again, this is the kind of thing where you're just kind of chugging along, looking for a contradiction, and you might not have one yet, or it might not be obvious to you yet what that contradiction is going to be. So at line 8, I just keep going, right? So I'm like, well, look, if I can get this not A by itself, and I can peel this off, right, and that'll leave me B. So not A by simplification on line 7, right? And then I can do a disjunctive syllogism on that, and that'll leave me B by itself. So that's disjunctive syllogism on lines 5, right, and line 8, right? And now I've got B by itself. Well, let's see, I can use that here with this half. So if I got this by itself, and I can, again by simplification, right, on line 6, then I'm going to have C by itself. Oh, and now we see, right, what our conclusion is going to look like. We're like, oh, well, I've got not C here, right? So I write that down. So now I've got C and not C in the very same subproof structure. How did I get the C again? That was modus ponens on lines 9 and 10. How did I get the not C? Well, that was just simplification on 7. So simplification on 7. So now I've got down here, and I've got an explicit contradiction, but to really discharge the assumption properly, I have to put those together. So that's just C and not C by conjunction, right, on 11 and 12, right? And now I've proved in only 14 steps, not T, right? And I did that by indirect proof, right? And that started at lines 4 and it went through line 13. And you can see that the assumption of T, given what you've already got here, will lead inevitably to a contradiction by logic. And that shows us, right, that not T is the thing to believe. We've just demonstrated it indirectly. Bravo! Okay, I'm back to do another proof. This time, again, indirect proof. And we're going to do number 9(5)b this time, right? So our premise, our solitary premise this time, is this conjunction of A and not B. And what we're trying to show is it's not the case that A if and only if B. That's our sought for conclusion. So we'll write that at the bottom. So it's not the case that A if and only if B, right? And that seems like it should follow, right? If you're already committed to the idea that A and not B, then it's not going to be the case that A if and only if B, right? Because you've got not B. This is a thought, right? But now how are we going to prove that? Well, we're going to use indirect proof. This looks complicated. It's not a conditional, right? It's a big negation. And so the simplest way, again, is going to be to draw that subproof line all the way up, right? And assume the opposite of what we're trying to show. And in that case, right, in this case, that's A if and only if B. That's an assumption that we're making for indirect proof. Assumption or IP, right? Okay, now what are we going to do? Well, again, this might not feel comfortable to you until you've done a few of these, but basically you just take the pieces you have and you start to break them apart into smaller pieces, and then eventually you're going to see how to construct a contradiction. So once again, down here, we don't have any idea what contradiction we're going to have yet, and there might be more than one contradiction that we can prove from this, but we just need one, but we're going to need it in that spot. So that's what we're going for. All right, so how are we going to get there today or with this one? Well, again, I think you've got a biconditional here, so you can change that in if you like, or translate it. Anyway, you've got biconditional exchange, right? So that's this. And you've got A and not B, right? So that's the sort of thing that you can use simplification on. So let's break these apart first. So let's try if A then B by simplification on line 3. Okay, and now I'm going to get A by itself, also by simplification, on 1. And that's going to give me B, right? Because if I put these two together, I've got a modus ponens case at steps 4 and 5. And so now we see what we're going to do, right? It should already be kind of jumping out at you. I've got B all by itself on the subproof line here, and then all I really have to do is at step 7 write down not B, right? And then at the very bottom, right, I write these together again. And that's my explicit contradiction, and now I'm done, right? With the exception of filling in a few justifications. How did I get not B? That's a simplification on line 1. How did I get these? Well, I put 6 and 7 together. That's just conjunction, 6 and 7, right? So this is, turns out, a surprisingly straightforward proof. Conjunction 6 and 7 it is not the case that A, if and only if not B, by indirect proof, right? And that was lines 2 through 8 inclusive. Yay! I'm back again to prove another conclusion here with these premises using indirect proof. So this is another illustration of indirect proof. First step, let's draw our main line all the way down to the bottom. I don't know how long it'll need to be, but we'll give ourselves plenty of room. Right, then we know that we've got premises here, so we'll just put the justification over there. And step 3, right, you might be ready to get going. We're aiming for a disjunction this time. I mean, one way that you can prove these is to prove one of the two disjuncts and then add the second one. But we're just going to go for the whole thing and try to prove it using indirect proof. We write x or y. That's our sought for conclusion, right? And we're going to try to show it by assuming the opposite and arguing to a contradiction. Again, any contradiction will do, right? So we kind of remind ourselves that like anything that is explicitly contradictory can fit in there. And once you've arrived at that step, you're done. You get to get out and you've got the thing that you were trying to show in the first place. So here we need, it is not the case that x or y. That's the opposite of the thing that we're trying to show, which is x or y. Okay, and so now this is looking kind of messy, but we're off and running, right? So the first thing you might do here is note that this is an assumption, right, for indirect proof, and now we can go. This is, of course, going to be indirect proof, but you don't yet know what the numbers are going to be for the steps. Okay, so first, I think, like the most plausible thing maybe would be to do a De Morgan's here. So just start working on this. This immediately gives us not x and not y by De Morgan's on step 3. That's cool, right? Because now we can get not x by itself, simplification. And why did I want to do that? Well, I was looking up at the top, and it turns out that I can run a modus tollens on 1 using step 5. So I'll do that. So that would be not A or B, right? The negation of the front half of this conditional, right? And so how did I get that? By modus tollens, steps 5 and 1. Okay, so far so good, but now look, I've got another disjunction, right? And I can drive that negation inside, giving me not A and not B. That's exciting. Okay, so far so good. I've got those pieces. I could go ahead and simplify them. Maybe that's the best thing to do. So I just write them down so I have them explicitly as little self-standing pieces that can remind me what's going on. This is a De Morgan's, by the way, on step 6. This is a simplification on 7, and so is that one, simplification on 7. Okay, now I'm still not sure what I'm going to do, but it looks like I've got to use this piece. I was given it by, as a premise, and I do have a rule I can use to break apart biconditionals, right? And they give me the two conditionals as usable pieces, if you like, right? So one of them is that, and then the other one, of course, is this, right? And that's biconditional exchange, right, on 2. Okay, now what? Well, it may be, starting to look a little clearer what you might want to do, right? So let's try it. 11, let's simplify these. If A, then not B, right? That's by simplification, right, on 10, right? So far, that doesn't help me a whole lot, right? But let's try the other one, right? That's not B, then A, simplification on 10, right? And now I see something I can do, right? I've got a not A here, right? And I've got A here, so that means, right, at step 13, I can derive not B using, right, modus tollens again, and line 8 and line 12. So you can see that, right? Not B. And then that means I've got, right, at step 14, I've got B from step 13 by double negation. And now hopefully you can see what's going to take the place of that sad face, right? It's going to be a contradiction. It's going to be this contradiction. It turns out B and not B, right? Because I have the B here and I have the not B here, so, right? How do I get that B? By double negation, right? How do I get the B and not B? By conjunction, right? Steps 14 and steps 9, right? And then I'm done. I proved X or Y by indirect proof, right? And that was 3 through 15 inclusive. Yay! Okay, I'm back again, right? This will be your final indirect proof illustration. This time I'm going to work in 9.5 again, number H, right, or letter H. This one might be a little longer, and we may not work it all the way out, right? But I want to sort of set it up so that you can work it on your own if you're interested. Okay, so here we are. Once again, what we're going to try to do to start with is just draw that main line down all the way to the bottom, and then we're going to go for the conclusion, not A, right? That's what we're seeking. And of course, right now, we don't know how we're going to get there in detail, but we know that we're going to use indirect proof, right, somehow. Okay, all right, so what do? Well, again, I set up my subproof structure first. So that's all the way down to the bottom. I'm going to want a contradiction here at the bottom, and I'm going to want the opposite of what I'm trying to show at the top, and that's just A, right? What do I need right here? That's right, assumption for indirect proof. Okay, so that should be familiar. You've already done some of these, or you watched me do them anyway. Now what do? Well, remember that the stuff that's above and to the outside is available, right? And so we go back, we look at line 1. It's clear that we can use a modus ponens on that, right? So that gives us B or C as a standalone piece. That's modus ponens, lines 1 and line 5. Okay, now what? Well, we've also got step 3. These are simplification options for us, so let's try to do that. We'll get D by itself. That's a simplification on line 3. And the one that we're maybe more interested in, right, that's not F, right? A simplification also on from line 3. Okay, so far so good. Did that get us anywhere? Let's see what we want to do next. So I think there's going to be lots of ways to solve this proof, right? But one way would be to use the rule of dilemma. So you might look at this and sort of see what kind of candidate for dilemma we've got from the available steps. So notice that right here, right, you've got the disjunction that's part of, right, dilemma. And notice that you've got the fronts of the two conditionals here at 4 and here at 2, right? So that means if you've got B or C, which you do inside the subproof, then you should be entitled to write down these two pieces. That is this one, right, and this one. Okay, so let's do that next. So we'll write these down like this, right? We've got B or C, so we've got F, or that whole piece, which is D, if and only if F, right? The biconditional. Now, our rule there, again, is dilemma. How did we get that? Well, we used line 6, that's the or, right? Lines 4 and line 2, right? So that's a little complicated, but hopefully you see that now that I've pointed it out, that that's, should feel intuitive to you. Okay, so far so good. Now what? Well, we've got something else we can do, and that would be this, right? Over here, we've got, even though you might not see it right away, this is just an or like any other or, and you've got the negation of this side of it here, which means that you're entitled to write this down all by itself, D if and only if F, right? 8 and 9 by disjunctive syllogism. So far so good. Well, we know what to do with those, right? Because we've done this a couple of times now. So it's step 11, right? We'll break this apart, right? Or take the biconditional and spell it out into its logical equivalent statement, right? So that's biconditional exchange, right, on 10. Okay, well, why did I bother with that? Well, I'm headed for a contradiction. So now let's break these apart. We'll go with if D then F by simplification on step 11. Right, we've got the not F there, right? So that means at step 13, I'm entitled to write down not D, right? Because I have the not F, and let's say if D then F, and not F, so therefore not D, right? That's modus tollens. And it's from lines 8 and line 12. Okay. And now it turns out, miraculously, right, we are already done. Because here we've got a D and here we've got a not D inside the same subproof. So we can just write down D and not D. That's at step 14. This again is just conjunction of the relevant steps. In this case, that's 13 and 7. Right? And amazing, we're done, right, already. So I went ahead and worked this one out, right, but you might play around with it and see if there are other ways that you could solve this proof besides this one.